Problem background. Deflection of structure can occur from various sources such as load, temperature, fabrication error, or settlement. Deflection in structure must be limited in order to prevent the cracking of attached brittle material such as concrete or plaster. The structure must not vibrate or deflect severely in order to appear safe for its occupants. Further, too much deflection on one member may impact the structural integrity of another member that it supports or the stability of the structure as a whole. The first picture on the left shows the deflection of the beam after years of overload. The primary goal of the assignment is to model engineering reasoning and to determine the effect of what is changed on what is measured for specific deflection of beam circumstances. Next, defining the problem. Beams can experience deflection due to different factors like load, temperature changes, error in fabrication, or settling. It is necessary to work for deflection to avoid the formation of cracked delicate material such as concrete or plaster. To maintain the perception of safety for occupants, beams should not undergo excessive deflection. Additionally, if one member deflects too much, it can affect the structural integrity of another supported member or compromise the overall stability of the structure. Then, draw the free body diagram of the simply supported beam of span length L under applied load P in the middle and identify the support reaction R1 and R2. Calculate the value of support reaction R1 equals to R2 equals to P over 12. Sketch the deflection shape of the beam under the applied load. Write equation of Mx and apply Macaulay method to obtain the slope equation and deflection equation for the beam. Ei d of 2y over dx power of 2 equals to Mx equals to P over x minus Px minus L over 2. Ei dy over dx equals to P over 4x power of 2 minus P over 2x minus L over 2 plus Ci. Ey P over 12 x power of 3 minus P over 6 x minus L over 2 3 plus Cix plus C2, where Ci and C2 are constant. Boundary condition x equals to 0, y equals to 0, C2 equals to 0, y equals to L, y equals to 0. Ei times 0, P over 12, L3 minus P over 6, L minus L over 2, 3 plus Cil. Therefore, 0, P over 16, L3 plus CL, Ci equals to negative P over 16 L2. The slope equation Ei dy over dx equals to P over 4x power of 2 minus P over 2x minus L over 2 to P minus 16 L2. Deflection equation Ey P over 12 x3 minus P over 6 x minus L over 2 3 minus P over 16 L2x, where the E value is 0 over 2 times 10 to the power of 9 and Newton meter.
Analyzing the problem, provided and gathered information to design hollow beam includes material for the hollow beam, which is multiple box, the overall beam length of 30 cm, and lastly 2 beam shapes and sizes, which are square, rectangular, and triangle, but in our case we choose square and rectangular. The dimensions for our first beam are as follows. For the outer dimensions, the beam width and depth are the same value, which is 0.02 meter. However, the inner dimensions are 0.015 meter for both beam width and depth. Lastly, the thickness is 0.001 mm. Moving on from the first beam, the outer dimensions from our second beam is 0.02 meter for the width and 0.048 meter for the depth. However, the inner dimensions are 0.02 meter for width and 0.046 for the depth. And the thickness for our second beam is the same as our first. This slide shows the loading and beam supports and the equation for the moment of inertia for both of our beams. For our first beam, the moment of inertia is 4.585 times 10 to the power of negative 9 meter fall. And moving on, the moment of inertia for our second beam is 3.38 times 10 to the power of negative 8 meter fall. We conducted 2 tests with 2 different span lengths, which are 20 cm and 10 cm. And the weight of the load is 15 Newton. Implementation of the plan. Here you can see the before and after pictures of the testing for each beam supports.
For test 2, the length is 10 cm. So the maximum vertical deflection that we get for beam 1 is 0.5 cm and beam 2 is 0.15 cm. The support reaction is the same for R1 and R2, which is 7.5 Newton. Now I will talk about the deflection according to the theory. For test 1, the beam 1 Y max is 2.72 mm, while for beam 2, the Y max is 0.33 mm. The support reaction for R1 and R2 is 7.5 Newton. For test 2, the Y max for beam 1 is 0.34 mm and for beam 2 is 0.041 mm. The support reaction for R1 and R2 is 7.5 Newton.
Evaluating the outcome. What is the relationship between deflection and span length L? As the span length increases, the vertical deflection of the beam also decreases under the same loading. What is the relationship between deflection and moment of inertia I? As the beam moment of inertia increases, the vertical deflection of the beam under the same loading. From the theory calculations, the percentage difference between test 1 and test 2 for beam 1 and 2 are 87.5% and 87.6% respectively. On the other hand, from the test measurements, the percentage difference between test 1 and test 2 for beam 1 and 2 are 50% and 50% respectively. Both percentage difference between test 1 and test 2 for theory calculations and test measurements are about 40%. It can be concluded that the test measurements support the theory calculations findings. Issues and solutions. Issues. While crafting the beam model using our cardboard boxes, we have discovered that the depth and width of the box should not be too large or too small. This is because if the depth and width is too large, the beam will be too strong for deflection to occur, while a depth and width which is too small will cause the beam to become too weak and reflection will occur almost instantly. Apart from that, the supports for the beam needs to be stable as it may alter the outcome of the project. Solution. To solve the size of the beam problem, we went for a suitable width and depth that is not absurdly large or small. That way, we can obtain a more realistic result after conducting the project. Also, to solve the beam supports from being unstable, we attach it to two tables with tape so that the beam supports do not move while the beam on top of it is being loaded.